If it's negative, it's going to move to the right. Okay, so this one would move it to the right h units. If it was a plus sign, it would move it to the left h units. Okay, and then Tanaya, will you help me out with K?
K moves up and down.
Yeah. Okay, so this translates up or down. Okay, and if it's positive, what does it do?
It goes up, right?
Yep, positive goes up and negative goes down. Okay. So H does the opposite of what you would think it would do, and K does the same thing that you would do. So okay, so that's that. Finish copying that down while I message Erin, and then we will work on the notes together. Okay. All right, so your notes, the document that I posted on Canvas looks like this. But you don't have to have this. Obviously, you could just write all this stuff down by hand. So whatever you can do or want to do. So we're going to start off with just a basic definition. A basic definition. What is an inverse function? So an inverse function is a function that undoes the original function. Okay, so it like does the opposite of the original. So while you're writing that down, I'm gonna draw out like a little map of a function. So I might have my x values and my y values. F is gonna go from x to y. Maybe we have 1, 2, and 3, and then 4, 5, and 6. And so maybe 1 goes to 5, 2 goes to 4, and 3 goes to 6. So F has arrows that are going to go directly across from left to right. F inverse does the opposite. So F inverse. So the F with the -1 power we call F inverse. And it's basically just going to flip the direction of all those arrows. So they're going to go from 5 to 1, from 4 to 2, and from 3 to 6. Okay. So our F of X values for this problem would be 1, 5, 2, 4, and 3, 6. But if I'm looking at F inverse values, point values, I would have 5, 1, 4, 2, 6, 3. They all went in the opposite direction. Okay, I talked a lot and wrote a lot, so I'll give you a minute to copy that down. What questions do you guys have while you are writing? I'm gonna double check to make sure this is recording. Okay.
So does the F inverse always have the quotation around it?
Oh no, I was just putting the quotations around it to like indicate that's what we're saying. Like when we see F to the -1 power, you don't say F to the -1 power or F -1, you say F inverse.
Okay, so F to the -1 it equals basically F inverse.
Yeah, exactly. Okay, so we're gonna do an example. Our example, we're gonna use the function f of x equals 3x plus 6. And our example is gonna be to show the steps to convert this f of x function into f inverse of x. So we're looking at how to find f inverse of x. So the very first step for doing this is going to be to rewrite f of x as y equals instead. So in step 1, I'm going to rewrite as y equals 3x plus 6 instead of the f of x that I had before. What questions do you guys have? Okay, if there are no questions, we're going to move on to step 2. Step 2 is to swap or interchange x and y. So in step 2, I'm going to flip-flop where the x and y are placed. So where there's a y, I'm going to replace it with an x. Where there's an x, I'm going to replace it with a y. Questions on this step? Are you guys caught up on writing?
Yeah.
Okay. So then in step 3, we're going to solve for y. Okay. Now, solving for y is the longest step in this, so that's why there's some extra space. So in step 3, we're trying to get y by itself. So the very first thing I'm going to do is I'm going to subtract 6 from both sides. And I'm going to get that x minus 6 is equal to 3y. And then I'm going to divide both sides by 3. So I get that y is equal to x minus 6 over 3. What questions do you guys have about that step? Okay, there are no questions. We're going to move on to step 4, which is to replace y with f inverse of x. Okay, and remember we say this as f inverse of x. So we write it like this, but we say it like that. All right, so in step 4, I had to shift it a little bit, sorry. We're going to rewrite as f inverse of x is equal to x minus 6 over 3. Okay, what questions do you guys have? Okay, we're going to do one of the 4 examples together at the bottom, and then if we have more time, I'll come back and finish the rest. I'm pretty sure we'll have time for one of them, but not all of them, and I would really like to get through the rest of the notes. So looking at the 4 problems at the bottom of this sheet, which one looks the most complicated to you guys?
2.
2? All right, so we'll do 2 together. All right. So in number 2, the first thing we're going to do, step 1, is to rewrite f of x as y equals. So Brandy, can you tell me how to write that?
Y equals 5x minus 1 over 3.
Perfect. Okay, and then Tanaya, step 2 says to swap x and y. So can you tell me what I'm going to write for step 2?
It would be x equals 5y. Right?
Uh-huh. What else?
Minus over 3.
Perfect, yes. And step 3, Francesca, how am I going to solve for y? What should my first step be?
What is divide?
So it is dividing right here. What's the opposite of dividing?
Multiply by 3.
Yeah. Good. So we're going to multiply by 3 on each side. So we get 3x equals 5y minus 1. Brandy, what should I do next to make y by itself?
Divide.
By what?
By 1.
No, what operation is going on with the 1 right here?
Subtraction.
Yeah, so what's the opposite of subtraction?
Add.
Yeah, so let's add 1. So we'll have 3x plus 1 equals 5y. And then Tanaya, very last step. Well, in step 3, within step 3. How do I get that y by itself? Tanaya, maybe your microphone's off. I can't hear you, but you keep popping up still.
You divide, right?
What? Yeah, perfect. Very good. So I'm going to have that 3x plus 1 over 5 is equal to y. And then step 4, let's see, Francesca, is to replace that y with f inverse of x. So how am I going to write number 4?
Wait, repeat that?
So step 4 just says to replace that y with f inverse. So what should I write down here for step 4?
F inverse of x equals 3x plus 1 over 5.
Perfect. Good job, guys. That was excellent. Okay, were there any questions on those steps? Okay, if not, I'm proud of you guys. You did well. I'm proud of you guys, even if you have a question. But I'm proud of you guys. You did a very good job with that. All right, so does anybody need a minute to copy that down? Okay, I'm going to assume that's a no. So I'm going to flip it over. So in property 1, so we've talked about inverse functions. We've defined them. We figured out how to get them from an original function. So for property 1, it has these 2 properties that can be really helpful. So we're going to talk about those. So property 1, I really like this one. If x comma y is a point on the graph of f of x, then y comma x is a weird